My name is Dr. Todd Cielo. I've been a chiropractor in Tampa, Florida for 20 years. Welcome to the practice. One, I want them to sit down, fill out some general paperwork, patient demographics. Number two is I want to sit down and have a consultation with them, let them tell me their signs and symptoms, the reason why they're in my office, and how this injury has affected their daily life. Once I get back those signs and symptoms, how it's affected the duration, intensity, and frequency of those pains and complaints, then we'll do a series of either 3 or 6 x-rays. The actual test should not take us more than 1 to 3 minutes, and it's going to be in an open room. And the x-ray, you're going to have at least 2 or 3 feet all around you in the open room. And you're going to be looking down and looking up, going left, going right, and we're looking for movement of the bones. And that's it. For DXD reporting, we're looking for movement of bones. Whether it's in the neck, the thoracic spine, or the lumbar spine, we're trying to see if the bones are shifting forward or backward or wedging. So here is the front of your throat. Here's the back of your spine, which you can touch on your own. So whenever you look down and whenever you look up, we're actually asking the bones to flex and extend. And the bones should be able to flex and extend only a certain amount of millimeters and only a certain amount of degrees per a normal spine. When you're injured, bones usually slip forward more or backwards more. Therefore, we want to get exact measurement to the 100th of a degree. Hence, that's why we're doing the x-rays. The only reason why bones move a significant amount is from severe trauma. It's not from repetitive trauma, it's always severe trauma, a whiplash-like motion. Whenever there's degeneration, all that degeneration is the bone is actually deforming or the disc space is actually getting smaller. When it comes to movement of a bone, it's simple. The bone is moving forward or backwards or extending or actually opening up. And with the DXD, we're trying to actually measure that to a 100th of a degree. Ligaments have one responsibility in the human body: connect bone to bone. Just like in your knee, just like in your neck, just like in your fingertips. So whenever we're flexing the spine, we're actually stressing out ligaments only. And when the bones are moving too much forward or too much backwards, that's telling me that the ligaments are laxed. Hence, that's why we want to get a measurement, and then we compare that measurement to the normal population. Ligament laxity over a certain degree of millimeters or a certain degree of degrees is from one thing: severe trauma. Anytime that there's movement of a bone too much over a certain parameter, over the 3.5 millimeters, especially in the neck, that's telling us that that joint, and when I say joint, that means 2 bones, is more laxed. Therefore, that disc that's in between is going to have more chance of wear and tear on much rapid than age. Therefore, we need to be able to document that. Hence, that's why you're sending them to me. So then you're fighting for the future damages. For the neck alone, it's either 3.5 millimeters combined of looking down and looking up, or 11 degrees. And 3.5 millimeters is the height of 2 quarters on top of each other. That's how small 3.5 millimeters is. 3.5 millimeters is a quarter mile to the human body. So if it breaches that, there's a permanent injury involved. Anytime that we're dealing with a permanent injury, the American Medical Association allows physicians like myself to utilize that permanent impairment rating evaluation, so the attorney that's involved in the case can utilize that as a compensation table for future damages, for future medical expenses. Anytime that something happened years ago, your body always tries to fixate the segment involved. So you're going to have hypomobility. You're going to have less motion than more motion. Hypermobility means that the bone is actually moving too much, which means it's from recent severe trauma. Your body tries to fixate to the best of its ability to stabilize an unstable segment. Whether it's your knee or your spine, your body is always laying down scar tissue, or some type of calcification to shut down the movement of the joint. And if that's the case, it's old. But when something is moving to a higher degree over that 3.5 millimeter threshold, it's new, severe trauma. I would see osteophytic formation, some type of arthritis, and a joint that's not nice and plump. It will be actually desiccated, dehydrated, and much smaller than a normal joint like this. I would see the hypermobility of the bone moving forward and or the bone moving backwards over that 3.5 millimeters. So on a normal disc height and a normal joint segment, these are two bones right here, and then we have a disc in between. The height of this disc is very healthy, normal, good disc height. When we have something that's arthritic, there's a big decrease in disc height. So we know two things are going on with this old joint. We know that the disc space has gotten smaller, and we see that all the arthritis and all the lipping and spurring has formed. So this is an old trauma. The body's trying to fixate, stabilize the joint on its own. What we're trying to do here is on the same x-ray, we're trying to see if it's moving forward or backwards. And if it's moving forward or backwards, even in an arthritic joint, that's telling me that there's a new joint. There's a new trauma there. These are two bones that comprise a joint. This is the disc space. The disc has one responsibility: separate these two bones. Since they're separating these two bones, this is a nice healthy disc, normal disc height, and the bones are very box-like in shape. Therefore, there's no trauma. If we have an older disc and older arthritis, that's telling me that this disc has gone through trauma, because you can see the difference between a nice healthy disc and an older disc. And still on the x-ray that we're asking to look down and look up, even if it's arthritic, we're still looking for this motion. And if this motion takes place, that's telling me that there's new trauma involved, even though this is an old injured segment. Yes, because since this is moving forward and backwards, the spinal cord is right there. So that's getting extended and flexed upon, and the nerve roots, we have a pair of nerve roots at each section, those nerve roots are actually getting encroached or compressed. So not only is the disc irritated or aggravated or permanently aggravated, but the actual nerve roots and the spinal cord are being impinged from excessive movement. So this is the actual x-ray unit that we'll be utilizing for x-ray analysis. It's real simple. I'm going to have your shoulder touching the bucky. You have a big open space here, big open space on the left side of your body, and we're just going to be doing three simple pictures. One in neutral, one in flexion, one in extension, and depending if there's other signs and symptoms, I might have you bend forward, bend backwards, and neutral. So we'll be taking approximately 3 to 6 views of you. But each view will not take more than about 4 to 5 seconds. So once we finish the x-ray process, which should not take more than a handful of minutes, we're going to import those x-rays into the software, and we're going to be looking for two things: millimeters, the forward movement of a bone or the backwards movement of a bone, and or we're looking at the wedging of the bone. Once we're done with the x-ray procedure and we get those 3 x-rays of flexion, neutral, and extension, I'm going to send a copy of the 14-page report to yourself, to your attorney, to your treating physician, and to the insurance company. If you have any questions or concerns, you can either call me and I can go over the report with you over the phone and correlate that with your signs and symptoms, or you can come back into my office.